You are currently sitting on a rock that is spinning at over 1,000 miles per hour. If Earth stopped instantly, you would be launched eastward at roughly 1,000 mph, and you would indeed be a ballistic projectile relative to the ground. Air resistance at supersonic speeds would be catastrophic, likely vaporizing or crushing you instantly, rather than simply slowing you down gently before you stopped. Everything on Earth is locked into a planetary momentum that has been spinning since the solar system formed 4.5 billion years ago. The atmosphere, the oceans, the cars, the buildings, and you are all traveling eastward at roughly 1,040 miles per hour if you live near the equator, which is approximately Mach 1.35 and well above the speed of sound. If the Earth stopped rotating in an instant, the atmosphere would keep moving. An instantaneous stop would generate supersonic winds of about 1,000 mph that would obliterate virtually all surface structures globally, leveling trees and buildings in a massive wave of destruction. Oceans would slosh out of their basins. Water has mass and momentum, just like air, and trillions of tons of seawater would redistribute. The initial catastrophic sloshing and megatsunamis would occur within hours to days. Water would flow toward the poles because the centrifugal bulge would disappear as the planet assumed a more spherical shape. Fortunately, physics prevents this sudden stop. There is no known mechanism in the universe capable of halting a planet of 6 septillion kilograms all at once. But what if it slowed down gradually? What if the brakes were applied over decades, or even centuries, until the Earth stopped its rotation completely, though a tidally locked state requires the planet's rotation period to match its orbital period? Meaning stopping rotation does not automatically produce a 365-day day, since the planet would need external torques to reach that exact state. To understand how catastrophic that is, we have to look at why the Earth spins in the first place. When the solar system coalesced from a giant cloud of gas and dust 4.6 billion years ago, conservation of angular momentum caused the collapsing material to spin faster and faster. Planets inherited that spin. Today, that rotation does more than just give us day and night. It shapes the very structure of the planet. Because the Earth spins, centrifugal force pushes outward at the equator, bulging the planet slightly. Earth is not a sphere. It is an oblate sphere, roughly 21 miles wider across the equator than it is from pole to pole. If the Earth stopped spinning, that centrifugal force would vanish while the solid bulge relaxes slowly, causing water to flow toward the poles as the planet's shape shifts. The result would be a massive redistribution of our planetary water, exposing new land at the equator while raising sea levels at the high latitudes. Two massive polar oceans would form at the top and bottom of the world, separated by a dry, barren wasteland where the equatorial sea level used to be. The global ecosystem, already battered by climate shifts, would fracture as habitats vanished overnight. Without a daily rotation, our concept of time breaks down entirely. If Earth stopped rotating, a solar day would equal the orbital period of roughly 365 days, meaning the sun would rise once and set once per year instead of creeping slowly across the sky. For 6 months, the day side would bake under relentless solar radiation, while the night side would freeze into a deep, dark abyss. This extreme thermal gradient would drive a radical new weather system. On a normal rotating Earth, the Coriolis effect deflects winds, creating curving jet streams and swirling storm cells that distribute heat evenly across the globe. Without rotation, the Coriolis effect disappears. Instead of swirling storms, the atmosphere would settle into a giant, planetary-scale convection machine. Hot air at the equator would rise high into the stratosphere, rush directly toward the frozen poles, sink, and flow back along the surface toward the equator in ferocious, unyielding winds. Agriculture as we know it would become impossible. Crops require stable, predictable cycles of day and night, moisture and temperature. In this new world, you would have to chase the twilight zone, farming in a narrow, migrating strip of perpetual sunset that slowly circles the globe once a year. Yet the most terrifying consequence of a stopped Earth has nothing to do with wind, water, or weather. It has to do with magnetism. Deep beneath our feet, the outer core of the Earth is a churning, convection-driven ocean of liquid iron and nickel thousands of degrees hot. As the Earth rotates, the Coriolis effect twists these rising and sinking currents of molten metal, aligning them into a vast, self-sustaining dynamo. This magnetic field is the invisible shield that protects Earth from the solar wind, a relentless stream of high-energy charged particles blasted out by our sun. If the Earth stops spinning, that dynamo dies. The geodynamo depends on convection and rotation, but if rotation stopped, the field would weaken over thousands to millions of years rather than vanishing within a few centuries, with simulations suggesting a decay timescale of roughly 10,000 years. Without a magnetic field, the solar wind would eventually slam directly into our upper atmosphere, stripping away molecules through a process called sputtering. Over millions of years, Earth would suffer the same fate as Mars, losing its protective envelope of air and water to the vacuum of space, reducing a once vibrant cradle of life into a sterile, irradiated rock. Spin is not just a clock, it is life support. It is the engine that drives our weather, shapes our geography, and generates the invisible force field that keeps our air tethered to the ground. Every day, the moon's gravity steals a tiny fraction of our rotational energy through ocean tides, slowing our spin by about 1.7 milliseconds every century. Dinosaurs experienced days that were slightly shorter than ours. Millions of years from now, the Earth will spin even slower than it does today. But as long as that core keeps turning and that momentum holds, we ride this spinning rock safely through the dark. Which leaves a quiet thought hanging in the empty space between the stars. How many other dead, silent worlds out there stopped spinning long before life ever had a chance to begin?